Hello everybody, welcome back to Virtual School Physics is Fun. This is Puan Liao again. Okay, we have learned wave concept. Today we are going to continue with waves and we are concentrating on graphs of wave. There are two types of graph that we have to learn, that is displacement against distance graph, and later on we are going to look at displacement against time graph. Okay, let's start off with the first graph. Now, we have learned concept of amplitude. Can you remember what is amplitude? Okay, amplitude is maximum displacement from equilibrium position. All right, so from here, from this graph, this is our equilibrium position, and this is maximum displacement. Therefore, amplitude is shown here. This amplitude, okay, these two are the amplitude. Then wavelength. Wavelength is distance between two consecutive crests or troughs. Okay, so if you look at this crest to the next crest, so this distance is wavelength. Same here, trough to the next trough, so this is wavelength. Okay, so from a displacement against distance graph, so we can determine the amplitude and the wavelength. Okay, let's look at this graph. Can you tell me how much is the wavelength? What is the wavelength and what is the amplitude? All right, so you see from crest to the next crest, this is our wavelength. So it will be 50 minus 10. That gives us 40 cm. And the amplitude, this is our amplitude. So it is 25 cm. Okay, so the second graph that we're going to learn is displacement against time graph. Now, let's recall the meaning of period. Period means time taken to make one complete oscillation. Can you remember? Okay, so what is one complete oscillation? This is one complete oscillation. This is another example of one complete oscillation. So is this from trough to the next trough, or from crest to the next crest. All right, so here shows 4 different complete oscillation. Okay, each one of these are one complete oscillation. So if we draw them against a displacement against time graph, therefore this time taken here, this much of time here, is the time taken to make one complete oscillation, which we call period. So this is period. This is also a period. This one is also period. And so is this period. Okay, look at this graph. All right, so one complete oscillation. Therefore, this is period. From crest to the next crest, one period. One complete oscillation, so one period. From trough to the next trough, one complete oscillation. So this is also one period. Okay, can you tell me what is the period of this graph? Let's take the crest to the next crest. Okay, so it will be 0.5 minus 0.1. So that gives us 0.4 second. So the period is 0.4 second. We can also take from trough to the next trough, right? So it will be 0.7 minus 0.3, gives us the same answer, 0.4 second too. Okay, now the next concept that we need to know is wave speed. What is the relationship between wave speed, wavelength, frequency of the wave? All right, so all of us have learned from lower form that speed equals to distance over time. All right, so if we take the distance between two crests, which we call wavelength. Okay, and the time taken to make this distance, which is wavelength, example that I said just now, from crest to the next crest. So the time taken to make from crest to the next crest is period, right? So therefore we have speed equals to wavelength divided by period. Okay, speed v equals to lambda over t. And if we rearrange, we will know that lambda times 1 over t. Okay, we bring the lambda down, so 1 over t. And 1 over period, 1 over t is equals to frequency, right? 1 over period is our frequency. Okay, that is, frequency is number of complete oscillation made in 1 second. Whereas period is time taken to make one complete oscillation. So they are related to each other, right? Okay, so from here we form the relationship between speed of wave, wavelength, and frequency. Okay, so we have derived a formula that tells us the relationship between speed of wave, frequency, and wavelength. That is, V equals to F lambda. The popular formula, V equals to F lambda. So please remember this formula, okay? Now let's look at some quizzes, yeah, to make sure that we have understood today's lesson. Okay, now look at this graph. What graph is this? Is it the displacement against time graph or displacement against distance graph? Okay, look at the unit. Even though it's not labeled but by looking at the unit, we will know what type of graph it is, right? So this is in meter and this is also in meter. Therefore, it is displacement against distance graph. So from displacement against distance graph, we can determine amplitude and also wavelength. Okay, so how much is the amplitude? So this is our amplitude. So 6 meter. And the wavelength, how much is the wavelength? Of course, it is 4 meters. Okay, amplitude 6 meters and the wavelength 4 meters. Okay, second quiz, look at this graph. This is a displacement against time graph. What is the amplitude? Yes, very easy. Amplitude is 15 cm. Period. Since this is a displacement against time graph, so period is, this is one complete oscillation. So period is 20 seconds. And from the period, we can determine the frequency because frequency is equals to 1 over period. Alright, so the frequency will be 1 over 20 seconds, therefore 0.05 Hertz. Okay, the last quiz, look at this graph. This is again displacement against time graph. Okay, how much is the amplitude? Amplitude, so 0.2 meters. Period, this is one complete oscillation, so period is 0.5 second. And frequency, frequency is 1 over period, therefore 1 over 0.5, that gives us 2 Hertz. Okay, that's all for today's lesson. Thank you. We'll see you again